Welcome guys. Welcome to my electrodynamics problem section. Basically, I collect some interesting and people like to ask question in the electrodynamics and try to write a solution for it. Okay, so the first configuration is that we have a conducting sphere or whatever. We just have a sphere which is a shell, and then there is a uniform charge density Q. Okay, and then we want to find the total energy and the electric field. So electric field is basically very easy, just Q divided by 4 pi epsilon not R squared. So you can solve this by use Gauss law. If you don't know how to solve the Gauss law, you can check out my other videos. You just go to my channel and type the Gauss law. Okay, so electric field E, when the distance r is less is greater or equal to the radius of the sphere, this is the charge electric field. So we put out this is the total energy. So we just put this E in. So we get a half epsilon naught charge square. So this is r to the fourth. The electric field force r to the fourth, and the times the 4 pi r squared dr. So when I integrate r to infinity, so basically we integrate all the energy from r to capital R to infinity. Okay, now you guys can just follow the derivation. So the answer is Q squared divided by 8 pi epsilon, not R. Okay. And this guy is very also people like to ask. So I write down all the details. This is a little bit tricky. So suppose you have a sphere, but this sphere is solid. So the charge density Q is uniformly conducting in a sphere. So basically, the Q is just uniformly conducting, right? So the electric density, also the electric field is this guy and this guy. So from R greater or equal to R, you get the original guy. And this guy, you can use the Gauss law to solve it. But basically, it's uniformly along R, okay? So for this solid sphere, we just do the same computation. So for the R small r greater or equal to capital R region, we get the same configuration because outside the sphere that everything looks the same. But inside the sphere, we will have some contribution. So we just square this term. So you can say this. You can see there's a R squared and this 4 pi R squared term, and the numerator is R to the 6th power dr. So you guys can just follow my computation. So the first term is exactly the same. And the second term is this guy. So R to the 4th dr, R to the 6th, 0 to R. And then you get this guy. And then you get R capital R to the 5 divided by 5. Okay, so the answer is this. And then this is a famous answer. If you go to some test or some midterms and that everybody likes to ask this question. Okay, so I hope this videos helps you guys. Okay, be sure to subscribe to my channel. I will see you guys in the next videos.